All right, today we're going to be looking at section 4.3, quadratic functions. These are the objectives that we see here from the Learn section in Hawks. We want to calculate quadratic regression. We're going to determine attributes of quadratic functions. We're going to determine the maximum and minimum values. Determine quadratic functions for given graphs. We're going to graph quadratic functions. We're going to use quadratic functions to solve applications involving maximization and minimization. And then we're going to use quadratic regression curves to solve applications involving maximum and minimum regression equations. So I will be doing most of this in the calculator. I believe they're going to show you some tools to do it by hand, but I will be using technology. So in the gray box, we have the definition of what a quadratic function is, what it looks like. It's a second degree polynomial. So the second power is going to be the largest power that you see in your quadratic or in your polynomial. And this is a U-shaped graph, and here's an image of what one might look like. Here's a table of points, and then here is the parent function. All right, and then you also have the vertex definition, so what the vertex is and some of those definitions. Now, I did mention in a previous video that I would give you guys some parent functions and graphs. So if you come over to Blackboard in our course, go to Module 2, and then right below 4.1 you have 2 PDFs. So these are both easily found online if you just look for parent function graphs. So these are all the parent functions that you want to be familiar with in college algebra. Here is the quadratic, and it tells you some properties of these parent functions. So this is one of the ones that I have attached. And then if I go back, there's a parent function plus that I like this one because it's in color and it gives you just a few more characteristics about the parent function graphs. Now this one has a lot more than what we will cover in college algebra. So like the first 2 pages, I think, are basically what we're going to look at. Maybe this first and second one. I don't think we're going to be doing step function, but absolute value we'll probably see. And then after that, this is good, definitely good for quadratics, which we're going to be doing now. Got vertex and axis of symmetry and a lot of other things. So I guess the first 3 pages, maybe 1, 2, 3, are helpful. Not everything. We won't do everything. But after that, then you get into conic sections, which I don't think we'll get to. Trig, which you'll use that in calculus. We won't use any of that. So all the way down through like the last page. The last page we will use later. This talks about transformations of graphs. And some of this I like, not all of it. We'll have to see what our book does compared to what this, and I'll point out what I like and don't like. But anyway, that's here now. The graphs that I have been promising to get up, they're here in our Blackboard course. And again, you can find these online if you search for them. So here are some of those terms. Now, some more examples, some more images that they give you talking about some of those properties. Again, I'm going to go over all of this for you in the video examples when we start working the examples in Hawks. It looks like they're already talking about the transformations. Yes, and so some of this right here, when I say H is positive, is letting you know what direction the graph is facing, like if it's going up, opening up, or opening down, like this one. So when it's negative out front, it's going to open down. If it's positive, it opens up. Which normally this is in its own section when we talk about transformations. But here, let's talk about them here. So vertex form. So the vertex form, similar to what we saw in the first section, is what you get as if you were to complete the square for a quadratic function. The A, the coefficient out front, is what we usually talk about as our let's see what they call it. Can't remember the name of it, but it's losing my train of thought. It tells you how wide or narrow your graph will be in layman terms. So if this A value up front is bigger than 1, it will make your graph narrow. You want to think about it as like exercise. If you exercise a lot, you should lose weight, get smaller. If this value is less than 1, but between 1 and 0, let's say like a half, then it will make your graph wider. So that's that description. H is your X coordinate for your vertex. It tells you you're going to shift left or right, and it's going to do the opposite of what you see in the parentheses, the opposite sign. The K is the Y coordinate of your vertex. It tells you up or down, and it will do exactly what you think it will based on the sign. And then this one just puts them all together. Now there is another one that we'll see with B in there, but I guess that's one that we don't use very often. Here's some examples provided by Hawks. And they give you some technology, which will do all that together. This is a little bit newer. I do like that they're giving this now. Depending on the form you're given, so you can be given your equation in standard form, or you can be given in vertex form. Based on what form you're given, sometimes you want to find the vertex, so that is the middle point. Let me go back and point that out. Vertex, given a graph, is going to be that center point, that highest point you get to, or the lowest point if it's going the other way. So a lot of times we want to know what the vertex is. If you're given standard form, you can do negative b over 2a as part of the quadratic formula. That will give you the x coordinate, and then whatever you get there, you can plug it in to the function and solve it and get your y value. So this is one way. And then another way, you can do negative b over 2a, and then the other part, similar to the quadratic equation, you can do the 4ac minus b squared. That's the part that's under the square root, all over 4a. And that will give you the y value. So both of those will give you the vertex, that's a little bit newer. Not really sure who came up with that one, but it's a neat new thing that you can use, as far as new to me anyway, within the last, I would say, couple years. And then some more examples, a few more examples, which you can look at those if you like. So now quadratic regression. This specific command varies with the technology, so I'll show you how to do it when we get there. But let's look at what they do. So you have a scatter plot. You're going to input those stat points like we did with the linear regression, and then we're going to do quad regression from the calculator. We'll get an output. We can also have it to graph if we would like. And I can show all of that, and then here's an example of it, and they're kind of walking you through their button pushing process here. Maximum and minimum. Okay, so that basically deals with quadratic. Okay, we're going to find the max or minimum. I don't think there's anything special that we need to point out. If your graph is opening downward, it's positive, it's going to have a maximum. No, this is negative. If your graph, your function is negative, the leading coefficient is negative, your graph will be opening down, you will have a maximum. If your leading coefficient is positive, it will open up, you will have a minimum. And then here's some examples of some application problems, which they all just lend themselves to quadratic formula, and we'll find vertex. And then here's a couple more examples of them using regression. And then the last page is just some calculations and some steps as far as using the calculator to find minimum and maximum. So with that, we're going to go ahead and jump into Hawks and start solving some of these problems.